Hello everyone, welcome to this new video where we are going to go through transpose matrix, where we receive as input a 2D integer array matrix and we are supposed to transpose the matrix. So this is an example of the transposal. You receive this as input and you transform into this. So I will not take this as example because it's a square matrix. It doesn't really explain you exactly how to solve this, but rather I'm going to use something like this. So let's take this matrix as input. This is a 2 by 1, 2 times 3 matrix, right? 2 times 3 matrix. Now that I have my 2 times 3 matrix, if I want to transpose it, what will it look like? So the one at position 0 0 will go back to 0 0. The one at position 0 1 will go back to 1 0. That's the transposal. That's why the B is here, to 1 0. The one at position 1 0, which is C, will go back to 0 1, which is here, 0 1 C. The one at position 1 1 will remain at 1 1, which is 1 1. So we have the G here, and then the one at position 0 2 we go back to 2 0, 0 2 go back to 2 0. So this is the E here, and the last one is here, F. So there's two things you need to be able to understand here. What is happening is that each of the element that was at position E G will now go to position, will now navigate to position G E. So this is the first thing you need to be able to understand. Once you have this information in mind, you know that okay, element that was at position IG will move to GI. So this kind of gives you what you are going to put into your logic. And then after this, the next thing you need to be able to understand is that you are actually transforming a matrix of size n times m. So this is the first thing you need to be able to understand. And the second thing you need to be able to understand is that you are transforming a matrix of size n times m to a matrix of size, you guess it, you see it, m times n. So basically what you are going to do is that you are going to take your input, your input matrix, you create an empty matrix with the size of the transpose, which is actually the m times n, and then when you are looping, you just apply this operation. So that is how we are going to solve it. Now that we know how we are going to solve it, let us dive into the code of it and see what it look like. So the first thing we need to do is to create the result matrix, which is what we just did. So in C++ it will look like this. I'm going to have like a vector of int. I will call it result. When you initiate the matrix, you can just give the size of the matrix. So the actually m, we have been talking about a matrix of size m times n. M is actually the size of the first element, like the size of the different rows. So I'm gonna say matrix of 0 dot size, and then each of the elements should be a vector of int of size matrix dot size. So this is my n times m matrix, m times n, I mean. So now that I have this, I'm going to loop into the element and create the transpose version. So I'm going to return result at the end. I'm going to return my result at the end here, but here I need to make the loop. I'm looping like the normal matrix. This is the row, and I'm looping to the column now. And for each of the element, what I'm going to say result of what? Of call row will now take matrix of row call. So this step is actually what I've described here, like creating a matrix of the transpose size first, and then this is actually what has been described here, just swiping the element eg into gi. So let us run this and see what it gives. So we have everything green. Let us submit. Nice, everything is green, performing pretty good. So yeah, so this is my approach of solving this. I hope you do enjoy it. Feel free to leave me any input. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.